So, hello guys, this is Ashish Rai, and today we are going to learn about most basic laws of the nature that governs the nature, and like why a body which is at rest always will be at rest, like a duster that is placed here, it is rest and always will be here for as the time passes, and why moves things moves free in the space, and why a ball that I have, let us give me example, that I have a ball or a chalk that I spit it on the floor, then it stops after covering some distance. Why that happens? So already you have guessed what these are, what I am talking about. I am talking about the Newton's laws of motion, the most basic laws of nature, and how the nature's works and how a body's motions covers. So, firstly, there are some things firstly there are experiments done by most philosopher Galileo, and Galileo come into the picture, and he done some experiments. After he said that if a body is at rest, if a body is rest, like a duster that is placed on the board is at rest, it will always remain the rest. And if a body is which is continuously at moving with a constant velocity will always tends to move in that direction with that velocity. So if there is no external push or pull to the body. So Galileo called this statement as the principle of inertia. So principle of inertia. According to this, if a body who is at rest will always remain at rest, or if a body is moving will always going to move in that direction with that velocity forever. If there is no external push or pull, like I don't have pull or push the body externally. Firstly, you can say that what is inertia? Inertia generally means a resistance to change. Like if a body is at rest, it comes to in motion, the resistance. The motion, the body is in motion and is come to rest. It is resistance, and the change in direction, it is resistance. So inertia means resistance to change. After that, Newton, the most brilliant mathematician and physicist, come into the picture. And the amazing thing is that the year in which Galileo dies is the same year in the year in which Newton born. So Newton's first law, he gives three laws of motion that covers the motion of an object. The first law, he gives the principle of inertia. Newton's first law is principle of inertia. He restated the Galileo's principle of inertia in Newton's first law. So everything is clear about this. Newton's first law defines two things. It defines zero force. We will talk about this after covering the three laws. And second is inertial frames. So after getting this, we can talk about Newton's second law. Newton's second law states that, let me do an experiment. If we have a body, like I am in the car, I am driving the car or a bike. So let's give an example. I am here. Is my car. It has some velocity u. Generally, u means something like 5 meters, 10 meters per second. Or at time t1, many sense I see my watch at that velocity, that will give me like 5 minutes, 5 seconds or something time. After some time I want to change, or I want to increase its speed or its velocity. Let after time, at time t2, so at the time passed t2 minus t1 is delta t. After covering some time delta t, I see my car which has at velocity v now. So I will generally take as v as greater than u, like I have here is 5 meter per second velocity, and here I have 20 meter per second velocity. So let us there is term called momentum, PMV. Momentum generally defined as the sum product of mass of a body into the velocity of that body at that instant. So let us calculate the momentum of this P1. Let it P1 is equal to mu, and it is P2 is equal to V. And let me calculate the change in momentum and also the rate at which it is changing, like is equal to P2 minus P1 divided by T2 minus T1. So I have changed the momentum from mvu to mv to mu is finally mu at time t, in time t delta t, t2 minus t1, and let us put the values mv minus mu divided by t2 minus t1. Generally we call it, let m is common, v minus u divided by delta t, and this term should be known as is called acceleration. So, and this is known as the force applied at that distance delta t from this car, it as so that it changes velocities from u to v. So this is called force. And what is a force? Force, can we say that the rate at which momentum is changing. So Newton's second law is this: the rate of change of momentum is called force. And after that, so Newton's second law defines force. It defines what is a force is, and now that is now we talk about third law. Third law. Let I have two bodies, like I have ball in this hand and I have ball in this hand. We collide them, and considering fully elastic collision, and there is no change or heat of a one body, there is no external heat applied, or no external force applied, no external energy, and not an external energy released from that bodies. And like it, one balls, this is mass m1, a ball at velocity v1, so let me u1, and here is velocity as b ball, mass m2, velocity u2. So let us collide them. Here they are collide, and as the collision is fully elastic, they gone backward from where they come. So here some let the velocity v1, here is velocity v2, So getting something like you know conservation of momentum. So conservation of momentum says that the momentum is conserved in a system. The momentum initially is equal to momentum finally, and momentum of 1 m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So let's things get separated. M1 u1 and sorry, for m2 u2 there is a minus m2 v2, and here is m1 v1 minus m2 m1 u1. So as we can say that momentum is converged before the collision and after the collision, we can say that the value of this equal to this, and considering this initially, we can say that m1 v1 minus m2 m1 u1, and at the rate which is changing, गलत हो रहा है and so this is amount is constant. So it is a constant number, it gives you a constant number. It means the derivative of this is equal to 0. So let us calculate derivative of momentum, change in momentum, which is equal to d by dt of m1 u v1 minus m1 u1, and this is equals to 0, and here is you can say that is delta t m common, and v minus u is equal to m1 a, the acceleration, and this is equal to force of first body that applies on second. As momentum before the collision equal to after the collision, and which is equal to the force applied by second body on first body, which is equal to force applied by first body on second body. And as we say that the derivative of these are 0, so that means force F12 plus F21 is equal to 0, so there is a negative sign. This means the first ball as second ball, the force on which they collide, and they give the force after the collision to each other. So that is way the force exists in pairs.